A bulb of constant volume is attached to a manometer tube open at the other end as shown in the figure. The manometer is filled with a density one third that of mercury. Initially, H was 228 centimeters. Through a small hole in the bulb, gas leaked, assuming pressure decreases as dP by dt is equal to minus Kp. If value of H is 114 centimeters after 14 minutes, what is the value of K in R inverse? Use ln 4 by 3 as 0.28 and density of mercury as 13.6 grams per ml. So firstly, let's see what we have been given. We've been provided with an expression of dP by dt. Let's derive the expression of pressure from this. So P would go below dP. It becomes dP by P is equal to minus K dt, and integrating this from P naught to some P, and T is integrated from 0 to T, and this comes out to be ln of P divided by P naught is equal to minus KT, or it can be written as P is equal to P naught e to the power minus KT. Now we know that at T is equal to 0, the pressure of the gas was equal to the pressure of the atmosphere plus pressure due to the manometer height, right? So when we calculate the pressure in terms of centimeters of mercury, the pressure of the atmosphere will be 76 centimeters plus that of the height will be basically the height, that is 228. And since the liquid inside, which is being used for manometer calculations, is one third the density of mercury, this quantity will be divided by a 3. Okay. So this final quantity comes out to be 152 centimeters of mercury. And this is basically the value of P naught. Why? Because it is the pressure at T is equal to 0. So our expression becomes P is equal to 152 times e to the power minus KT. Right. Let's move to the next page. P is equal to 152 times e to the power minus KT, right? Now, at time is equal to 14 minutes. Okay. The height becomes 114 centimeters. That is, the total pressure therefore becomes 114 divided by 3 plus 76 in terms of centimeters of mercury, right? And this becomes 114 centimeters. Okay, so basically what we have now is 114 is equal to 152 into e to the power minus k times 14 minutes, right? And this is from where we would get our value of k. So we can write that k is equal to the logarithm of 152 divided by 114, right? And this entire thing divided by a 14 due to the minus sign. So this turns out to be 0.28. Okay, because this basically turns out to be 4 by 3. When you calculate it, you'll find it. And into a 1 by 14, right? So this is basically 0.02. But remember, this is in minute inverse. To convert it into R inverse, what will we have to do? We would have to multiply this by 60. So this gives us a 1.2 R inverse quantity. And so our answer to this question becomes option B.